Hi all. See this, for this particular problem, we are going to find out the orthocenter. So what is the orthocenter? Orthocenter means that it's a point of intersection of the altitudes. That means if we need to drop a perpendicular from one vertex to the base, or in such way that how we draw the height or altitude, that intersection will give you that. So obviously, we need to find out the vertices, right? Now here the vertex is given in some unknown form where the area is given, right? So let's first go ahead and follow the steps to find out that area, right? So here I will go ahead and say that let A be the area. So therefore, that mod of A will be equal to 1 by 2 determinant of k minus 3k 1, and then we have 5k and 1, and here we have minus k 2 and 1. This is a determinant. Now we apply the row operation little bit to make our determinant little bit simpler. So let's go ahead. So we'll get it as 2k. If I add it, we'll get it as subtracted 3k minus 2, we'll get is 0. So what the operation we make? We make the operation as R1 is equal to R1 minus R3. Now let's change that. We'll get it as 5 plus k multiplied by this will be k minus 2 again. Again we have 0, we have minus k 2 and 1. So what's the operation we make? We make the operation as R2 is equal to R2 minus R3. That's it. So by this way, we are able to simplify our determinant, okay? Now see that we are able to expand it with respect to the third column. So therefore, we'll get it as 1 by 2. This is the position, so minus 1 whole to the power 3 plus 3 multiplied by 2k multiplied by k minus 2 plus 3k plus 2 multiplied by 5 plus k. So that gives me the determinant expansion. Let's go ahead and make some little bit of more calci here. So if I go ahead, we'll see that 2k square minus 4k plus 15k plus 3k square plus 10 plus 2k, and that's it. So therefore, we will add the last line here to calculate at the quadratic equation form. So 5k square. Then we have that as 4 and 15, 11 and 2, 13, 13k. And then we have that 10. So plus 10, and that's it. So this is the determinant. But obviously to find out the determinant, it says that the area is 28. So the A will be either plus or minus, right? So let's apply that. So therefore we can say that as area is given, we can say 1 by 2 5k square plus 13k plus 10. That's equal to 28, but we'll have to add plus minus sign. That's imply that 5k square plus 13k plus 10 is equal to 56 plus minus. That's imply that we'll get a both quadratic equation 13k minus 46 equal to 0, or we have that equation as 5k square plus 13k plus 66, and that's equal to 0. Now it is obvious that for the second equation, right, the discriminant definitely be less than 0, okay? So I don't, if I write down that equation number 2 and the first one as equation number 1, we'll say that for 2, the discriminant is less than 0, okay? So no real k. So we just ignore that equation. Let's come back to the first equation. If I come back to the first equation, so we'll say that by 1, we can easily factorize this. So if I go ahead and factorize is 5 into 46, so therefore we'll get it as 23 and that, okay. So by 1 we can factorize as 5k plus 23 multiplied by k minus 2 is equal to 0, okay. Yeah, that's it. So that's why we get the value of k now. Now see that here it is given already that k is an integer. So therefore it implies that the required values of k is only equal to 2. So we'll ignore that minus 23 by k because that is not an integer. Okay. So that's it. I just give you the condition also that k belongs to the set of z. Okay. So as k equal to z, so we'll say that vertices are, so let's go ahead. We just substitute k equal to 2 here. So 2 minus 6. Then we have 5, 2. And then we have minus 2 and 2. That's it. So that gives you the vertices. Let's go ahead and try to sketch the equation. Okay. Now see that for 5, 2 and minus 2, 2 whatever, right? For that y coordinate are same. So therefore it is actually lies in a horizontal line. So therefore we can consider that triangle as this. So this point I consider it as 5, 2. I consider the next point as minus 2, 2. And obviously somewhere else we have my a coordinate. A will be 2 minus 6. Let us put as C, let us put at B. Okay, that's it. So that's will be our triangle. Okay. Now what we learned that to drop a perpendicular, right, we need to drop a perpendicular to find the orthocenter. So here I drop a perpendicular. So I drop a perpendicular from A to BC, that is P. Now see that as BC is a horizontal line, okay, because the y coordinate is same, right? So therefore AP is actually parallel to x-axis, right? And obviously it goes on passing through 2, 6. So the equation of AP is x equal to 2. So let's write down the logic, right? Now see that BC is a horizontal line. So AP being perpendicular is parallel to x-axis. Passing through 2 minus 6. So therefore the equation of the line AP is definitely be x equal to 2. Okay. So that's it. That gives my orthocenter x coordinate. Okay. Now therefore we can easily see that option A and option D are the possible answer. Okay. Now obviously that it is half or plus half minus half, we don't know. So that's why I have to join another line here. So I just drop a perpendicular from C to AB. Let's drop that. So that may be Q. Okay. So see that here that we need to find the slope of AB. So it's a slope that means joining between 2 points. Therefore it is 5, 2, and also we can go ahead 2 plus 6 divided by 5 minus 2. That gives you 8 by 3. That means the slope of CQ is definitely be minus 3 by 8. So the equation of CQ must be equal to, is passing through 2 minus 2. So therefore y minus 2 multiplied by minus 3 by 8 is equal to x plus 2. That's it. So this is the equation of CQ. Now we just substitute that. So therefore this is my equation number 3. We have equation number 4. So we need to find out the point of intersection. So therefore by 3, 4, or actually we are trying to find out the point of intersection, we'll find y minus 2 is equal to minus 3 by 8 multiplied by 4. That gives you minus 3 by 2. That gives you that y is equal to 2 plus 3 by 2, and that's why it gives me the half. 2 minus 3 by 2 actually. So therefore this point of intersection is 2, 1 by 2, and that's actually known as the orthocenter. So therefore we'll get that orthocenter is actually 2 and half. So that's why option D is the correct answer. And here this point is as 2 half. That's it. So that's the problem, which is very easy. We have to apply all the concept and just remember that what is the definition of orthocenter? That is that we need to drop a perpendicular point of intersection, and that's it. Okay. So that's the easiest way to calculate orthocenter. There are different cases that circumcenter, incenter, and all that stuff. For the upcoming videos and all that, you can able to see all those remaining stuff, right? That's it. So hope you understood that problem. Thank you.